I just click this button, custom, and then specify value. And this is, again, after you double click on the error bars, this format error bar thing should pop up. And you just come down here and click custom, specify values, and then what are the values that I'm looking for? Well, that's the ones that we calculated here. So we're looking for the standard error, this and this. That's for the positive value, and the negative value is going to be just the same. Okay, so now I've got my error bars. So now let's ask the question again. Do you think there's, if I compare the averages here, the groups, do you think there's any comparison I can make that's going to be statistically significant? Yeah, perhaps the difference between the average leaf area of the fertilizer and the acid. And then probably, I'm guessing these two are probably statistically significant too, right? The difference there. So let's try comparing the fertilizer and the acid. So if I go back to my t-test calculator, let's run another one here. So I'm going to do the fertilizer group and the acid group. Okay. And so the mean for the fertilizer group was what? The leaf area now. What's the mean? What's the average for the fertilizer group? 20.8. Okay. And what's the standard deviation for the fertilizer group? 6.56. 6.56. Okay, and then the mean for the acid group, did I get that one already? No, the mean for the acid group is 13.35. Okay, so we'll put that in over here. And then the standard deviation for that is this one right below it, 3.72. Okay, and then I just have to, I think the sample size here for the fertilizer group is 4. The sample size for the acid plants, how many of those? We have 1, 2, 3, 4, 5, 6 of those. So I'll put 6 here. Okay, so far, does that look good? Mm-hmm. All right, so we'll hit calculate now, and here's our p-value. So that is actually just shy again, because remember it's got to be less than 0.05, and we're at 0.057, so we missed it by 7 thousandths of a p. Okay, so that is not statistically significant. So you should not include error bars, or you should not include an asterisk between these two, because while they do look quite a bit different, once you do the statistics on it, in the end, they're not such a difference that we wouldn't think that this difference is due strictly just to chance and chance alone. Okay. All right, so let's try the control and acid. I'm almost positive that the control in the acid group is going to be statistically significant. Okay, so let's try that one. All right, so let's go back here again. We're going to compare now the control and the acid group. So the control group, what was the average leaf area for our control group? Yeah, 26.87, that's this one right here. Okay, so put that in there, and then the standard deviation is right here, 12.42. Mm-hmm. Oops, didn't copy. Okay, and then we had, I think, 8 plants here for the control on the leaf area metric. And then the acid, average acid is 13.35 square centimeters. Oh, we got that. Oh, that's already in there. And then 3.72. Yeah, so we already did that one. Okay, calculate now. There we are. The p-value is 0.0251. So this, I believe, may be our only statistically finding in this entire study. Well, did we compare these two? I don't think we did. We compared these, and then we compared these, and these ones are statistically significant. Okay, so everybody, make a note. When I'm grading these things, here's what I'm looking for, since we've all done this. And I know that these are statistically significant now. When you copy and paste this into your official report, you're going to want to add an asterisk. And I'm not looking for anything fancy here. You can just go to maybe find find maybe just a couple of lines, I guess. Or you could even do something like a bracket. You could maybe even do a bracket like this. And then rotate it maybe. It doesn't really have to look all that professional, but it has to be in here. So we said the difference here between these two, right?
Mm-hmm.
I'm gonna make this a little bit bigger. So here is the comparison. I'm gonna make this a little darker and easier to see. Here's our badge of honor right here. A single solitary asterisk. And hold on a second now. I have to figure out what I'm doing. Oh, I take this box out. I don't want this box around my asterisk. How do I do that? Shape outline. There we go. All right. This is what all of yours should look like. Make a special note. You should have an asterisk right here. That makes sense?
Yeah.
Because that tells me that you compared this average leaf area and this average leaf area, the one of the control group and the one of the acid group, and this is a p-value of less than 0.05, which means when I look at these differences in the averages, I can conclude that it's very strongly likely that these averages are different due to the effects of the acid and not just some fluke in an experiment. Right? So you can go ahead and publish this. Go ahead and write to your favorite academic journal and say, hey, we found out that if you add some acid to pinto beans, it significantly decreases the size of their leaves. Okay, so that is a real finding that we did see here in this little small study that we did, 2-week-long study. So you want to keep that asterisk on there, and that's I'm going to be looking for that. Okay.
So that's going to be the conclusion?
What's that?
That's going to be the conclusion to that?
Well, yeah, the conclusion is going to be, so maybe this is, you're kind of done here with our graphing tutorial. You found basically everything I need. Basically, there's going to be 2 graphs. They've got to have error bars on them, and then I want to see the asterisk to show all the statistical significant differences. Okay. Both of them. Include both of them there, so you can copy this one too. And generally, the way that you would format these, this is how it would be in an actual paper, is that they usually don't have the title in there, like this says leaf area. They usually is just a graph, and then above the graph, they put a little legend that says something like this: Figure 1, the average leaf area of the 2 highest leaves or something. Usually in the legend it will tell you a little bit about what the graph is showing you, and this even tells us that it gives us a little hint into our methods, that we actually took the average leaf area, not of all the leaves, but just of the top 2 leaves. Okay, so this is called a legend, and it's important because you see how I've given this figure a name now? It's called Figure 1. And so in your results section of your lab report, when you're describing the data on Figure 1, you can now reference the name that you've just given it. So you can say, as can be seen from Figure 1, the average of the control was higher than that other averages of, the leaf area. So that's probably the way that I would go about it, is to give them this legend and just take the little title here out of there and put it in the legend instead. All right, so that's going to conclude our graphing tutorial. This is your graphs here. All right. There's the one comparison we didn't do yet is we didn't do the difference between these two, and I'll bet that these are even statistically significant as well. Actually, let's just go ahead and do that so you don't have to do it when you go home. All right, and then I'll know what I'm looking forward to. Okay, so the last one we're looking for stem height And between the control and acid, okay, so the stem height was 29.15, and the standard deviation was 9.03. Okay, acid group is 24.08, and standard deviation is 5.96. There's 10 plants in the stem height, plants in the acid group. Oh no, not even close. Okay, so the only statistically significant finding that we came out of this whole study was that acid significantly lowers the leaf area. That's really the only thing we found. Interesting. Okay, so now you know. The only asterisk that's got to be in your paper is that one right there. Okay, so then let me just quick highlight a few of the extra. I'll just quick run you through the rubric here so you know what you're going to be doing for the rest of the paper. So I'll just open up this plan criteria thing and I'll walk you through it. What's that?
This is the draft.
Yeah, this is everything that you want to include in your first draft. Okay. All right, so here's what you need. There's there's 10 points that I'm going to give you for formatting. So a fourth of this entire paper is due strictly just to how you format it, and what kind of a big part of it is your language. Okay, if I see a lot of spelling errors, if I see a lot of colloquial language like contractions, informal type of stuff, you're going to get docked for that. Okay? One of the things that you don't ever use in a scientific paper are personal pronouns. So these are things like I, our, we, she. So you wouldn't say, in this study we did this and this and this, or in this study I wanted to find out if I could do this so that we could do this. You don't say that. So for example, instead of saying something like I wanted to find out whether plants grow better or yada yada yada, you would say the question of interest, or you could say something like the aim of the present study is to determine if something affects plant growth. Okay, so you just have to be a little bit more clever to figure out how to word stuff so that you take the personal pronouns out of it. For whatever reason, that's just the way scientific writing is. Okay, make sure that you don't use contractions, so like isn't, haven't, can't, all those things. And then make sure you got proper spelling and grammar, so if that's something that you struggle with, maybe have somebody read over it. And I'll be grading this too, so if I catch those on your first draft, I'll be marking them up. And make sure it's double spaced with 1.25 inch margins, so bigger margins, because I like to use the extra space to annotate your papers. All right? And then also, real careful here that stuff's not plagiarized. You don't have to sound super sophisticated. I don't really care how detailed you are about some of this stuff. I really don't want it to be just copied and pasted. And it's really easy for me to determine if something's been plagiarized. Usually, like, the formatting of the text is different than the rest of the paper, or else I can tell there's just a total shift in the vocal tonation, or maybe it just sounds way too smart. I was like, there's no way that so-and-so knows that much about these plants at such a young age. All right, so I can figure that out. If I detect any of that, it's an automatic 0. Okay, so keep that in mind. And I have given people zeros on this on their first draft, and they usually come around and decision. Okay, so then that's all formatting stuff, and then the actual components that you have to have in your paper are spelled out here. So you have to have what's called an abstract, an introduction, a methods section, and a results section. The abstract, write this last because this is basically a summary of the entire paper. It doesn't have to be long, 80 to 250 words. So that's like 4 or 5 sentences or something like that. Okay, the introduction is where you're going to introduce the reader to everything that's known about pinto beans, and then describe why you actually did the study. Now, this is a tricky part because why you actually did the study is because I forced you to do it. But just pretend with me, this is where you have to do a little bit of role playing. Pretend that I didn't just force you to do this. Maybe you are somebody that's generally interested in learning how to optimize the growth of your pinto beans. Maybe it's a research group that was hired by a farming cooperative to figure out how they can extend the growing season or something like that. Be a little bit creative, but you're basically going to to describe a little bit of background information. So you're going to say pinto beans are yada yada in such and such a plant. They grow well in such and such a condition. Anything that's known about pinto beans and their growth, this is where you have to go out and do a little extra research. Okay. Now the biggest thing is that the sources that you use to gain this information has to come from what are called peer-reviewed sources. Okay, and these are really tough to find and even harder to understand. And this has always been kind of a struggle, a barrier that lots of people have to break through when they're getting into science. So the place that's safe to look for peer-reviewed sources that's free is just Google Scholar. So if you just type Google Scholar in there, you'll be able to find it. And if you just type in pinto bean, there'll be a whole bunch of articles that come up, and the ones that are accessible to you are the ones that have PDF here. And basically what you're seeing is this a list of all the scientific publications researchers have made that they've submitted them to what are called academic journals, which are just basically these organizations that have experts that rip the paper to shreds before they accept it for publication. Okay. And so you can go on and read through these. Now, fair warning, almost all of the stuff in here you're not going to understand at all. Okay, because the people that are writing these have given their life's work to studying these things. These are written by PhDs who have been studying pinto beans for probably 20 years, and they understand all the nuance of all the sophisticated, esoteric arguments. So I'm not expecting you to understand anything that's going on. But in each one of these papers, in the introduction, where they're, the very same type of introduction that I'm asking you to write, in that introduction, they'll always have at least a couple little snippets or fragments of stuff that you can barely make out because they're trying to catch the readers up to speed. So, for example, if we look at the first one here, it says, the first one says, the alteration of extracellular enzymes in pinto beans leaves upon exposure to air pollutants, ozone, and sulfur dioxide. Does that mean anything to me? Absolutely not. I have no idea what that just said. But I'm going to click on the PDF and see if I can't glean something from some sort of info about pinto beans from the paper. So when you click on it, here it is. They've got an abstract for us. So this is just a summary. This is kind of what you're going to be writing. And then they go right into the introduction. The first thing that it says is exposure of plants to air pollutants induces many changes in physiological and biochemical processes. That wasn't so hard to understand, right? They're basically saying that the air pollution can change how plants are. And so you don't have to find anything super specific, but I do want you to go out to these sources and see if you can't, when you're coming up and writing your introduction, pull out some of these things. And so maybe if I was writing the paper and I was writing the introduction, you could say that it's important for pinto beans to have the proper conditions in their soil. And then you can maybe even reference this paper because that's what they're referencing. And you probably actually want to reference who they're referencing. So this whole world of academia is kind of like a reference game. You're trying to beg and borrow concepts from other people, and that's pretty typical of academic writing. So I'm going to ask you to do that. Now, to get you started, if you can't find any sources, I did kind of dig around and find a couple that are somewhat kind of related. So if you go on that plant paper experiment, I've got 2 of them here, and I want you to use research up to 3. So 2 of them, this one talks about acid rain, which is kind of like, we looked at acid in our group, so that's kind of important. And then also, there's a kind of a nice article that talks about lagoons, of which pinto beans are a member, and it just talks about their importance. So you can use these as 2 sources if you want. Just go in there and grab out a little snippet of truth and reference it in your introduction. Any questions on the introduction? Okay, so this is a kind of a bigger point 1 because it does take a little bit of time to do all of this research. Okay, it's got to be at least 5 sentences. You got to have 3 peer-reviewed sources which are cited in the text. So like when you say something about pinto beans that you got from somebody else, just put a little citation there in the text. And then the very last thing of your introduction is to state your research aims. So you might say something like, the present study aims to determine how various conditions such as fertilizer and acid affect plant growth. That's all you have to do for that, okay? So then after the introduction, you jump right into methods. So this is where you describe everything that you did for the study. And this has to be in paragraph form. Usually people are like, want to treat it like an instruction manual where they say, step 1, do this. Step 2, do this. Step 3, do this. But that's not what you do. You're basically just kind of describing how you did the study. So it's kind of all going to be past tense. And again, this is where it's tricky when you can't use personal pronouns, because you can't say, I watered these plants. My fellow peers were doing this and that. You just have to say, avoid all those pronouns. So you might say, instead of saying, I water the plants, what would be a way that you say that you're not using personal pronouns?
The plant was watered twice a week.
Yeah, the plants were watered. Okay. Maybe this is a lot easier for you than it is for me. I always have a hard time doing this. Yeah.
Is there a specific amount of water that you've done? That
the water was just you can just say plants were watered daily by laboratory staff or something. Yeah.
Do we have a specific
I don't know. Yeah. We're just entrusting it to them. Okay, so this is where you have to kind of think back and remember. I think we put up a whole big notes on the board about how this was done. I told you to write it down and take a picture of it. So if you've got that, hopefully you do. Otherwise, see if you can't find somebody that has that info available to you. But you're going to want to basically describe this in such detail that if I had never known what this study was, I could take your methods and I could go out and do this study on my own. Okay, so I want to know the kind of thing. I want to know the following. I want to know what kind of lights did you use? How often were they watered? How big were the pots that they were in? What kind of soil? What kind of fertilizer was used? And I don't have that information, so that's okay if you don't put that down.
Oh, so do we supposed to mention that? Like
you should, but I didn't get a chance to catch it, so don't worry about it. Yeah.
Okay, so
so basically, as much detail as you know about it.
Okay.
Yeah. And you'd want to know the light. I think I said the light cycle was like I think it was on like a 14/8 cycle, so 14 hours of light to 8 hours of darkness. And then I would want to know how many beans you put in each pot, what it was for, what were the different conditions were. So one was fertilizer, one was acid, and if it was really good, you'd tell me the brand of the fertilizer pellets used. But again, I don't know that either, so you don't have to include that. But try and be as detailed as you can. Again, knowing this isn't really going to be published, but the more you can describe about it, the better. Okay, but the big idea here, though, is that it's in paragraph form, it's in past tense, and then you avoid those personal pronouns. The results section you pretty much already completed, and that's one of the biggest parts of the paper. All right, so you put in these graphs that look just like this for the most part. Put like this, where they have a legend. You put that in there, and you're about half done with your results paper already. So you should already be there, or it won't take you long to get there. Now, the second part of the results is you actually have to go, it's kind of redundant, but you actually have to go and describe the figure in text. And they do this because, let's say you downloaded a file that couldn't have the figures shown, or else you try to print something and it didn't come out on the copier or whatever. It has to be in the text as well. So for whatever reason the figures don't come through, this reader still knows what's going on. So this is where you have to be careful. In the results section, you have to describe the results in these figures, but you can't make any interpretations about them. That's not the section for the interpretation. So you can't say something like, the reason why the average for acid is lower than the control is because of blank, 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 blank. That's an interpretation. All you want to say is that the average is lower. You don't want to tell or make any conjectures about why it's lower. That's something you'd say for the discussion. Okay, so the discussion is where you bring back all those interpretations. So your results would literally be something like this. Figure, according to, you could say like the average stem height for the controls was higher than that of the fertilizer and the acid, and then you would maybe put after that parentheses figure 1, basically showing you that figure 1 is the one that will show that data. And then you could say something like the control average was this, the fertilizer average was this, the acid average was this, and then you go on and talk about the stem height. It's pretty boring, really. You just literally describe what the results are. Don't make any interpretations. reference all of the data by the figures from which they were found, and that's good. Oh, there's one last graph I want you to include on here, and that's the percent viability graph. So on this tab here, there's a little tab that says percent viability, and that's basically where you're just going to tell me how many of the plants grew to not grow. Okay, so like the percent viability for the control group would be the 14 plants, only 10 of them grew. So if you take 10 divided by 14, what is that? 10 divided by 14. I got it here. 10 divided by 14 is 71.4%. So the control plants, 71.4% made it. Okay? We can maybe just do these other ones here so you've got it. Then this next one here for the fertilizer group, we had 1, 2, 3, 4 out of 12 made it, which is kind of surprising. So 4 divided by 12 is 33%. Okay, and then the last one is going to be the acid group, which was 1, 2, 3, 4 didn't make it out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we had 6 out of 10 make it, and that's 60%. So this also needs to be in a graph as well. So you take this, you hit insert, and you put this in a graph. There's a percent viability graph. Okay. And this one actually, you know what? This one would probably be better in just a table. So why don't you just, because this isn't really so much an average. So this is more just a table. So you can maybe just put that as a table in your results section. So you might even just say copy and paste. And then maybe label this instead of figure 1 or figure 2, you can maybe call this table 1. Okay, and maybe make it look a little bit more prettier than this. But you should include this data here, and then you can, once you have this as a table, you can reference this data in there too. Okay, and this is actually kind of interesting that the fertilizer really actually destroyed the plants, which is kind of interesting. I'm trying to figure out why that would be, and the reason I think is because the only thing different we did to the fertilizer plants is stir them. And I'm wondering if there's like bacteria or fungus on the stir sticks that when we stirred it in the soil made them sick. I can't figure that out. That's the only thing. Hey, all right stuff to talk about in your discussion. Okay. All right. So, and that's a good segue here to the discussion. And you know what? I might actually change some of the results. This bar graph for percent viability, this should actually be a table now that I think about it. But then basically you're just going to need a bar graph for each of the 2 metrics, so that's stem height, leaf area, and then a table for the percent viability, and then also one table that contains all of your raw data. So that would be, the raw data would be this table here that's you've already got right here.
That's nice.
So you can find kind of a way to maybe arrange that somehow. All right, and then the discussion is kind of the last part where you just talk about what was interesting in the data. It is kind of interesting that the fertilizer made all the plants die. Why do you think that is? What could somebody do if they wanted to figure out why that was? If something went wrong in the study, then you might describe what went wrong. So for example, you don't know if my lab staff actually was watering the plants or not. So maybe some of the stuff that we found was because they didn't water the plants, or think about anything, or maybe at some point you accidentally spilled the plant and then you put a bunch of the dirt back in and put it back in the thing. Anything that went awry in the whole study, you can outline here in the discussion. So kind of whatever else you want a reader to take away and whatever is important that you didn't get to say in the other sections. So that's the paper. It's pretty big, worth almost the same as an exam. Again, you get 2 cracks at it. I will grade your first draft and send those back to you, and you'll have a time to review them. And you're actually going to have a time to meet with me and discuss your graded first draft too. So I've tried to carve that out. Again, this is a really important assignment because I think it's important that you at least produce something that's somewhat to the level that you might encounter out in the professional world, being as this is a kind of a gateway into higher level biology classes. So right here, November 28th, all we're doing, this is basically a day where we don't have any lab. It's just going to be an open lab for me to meet with you about your scientific paper. Okay, so when you get your graded first draft back, and if you have any questions about that, now that's the time where we can just sit down and I can give you kind of a detailed feedback on what I think you should do to make it really nice. So there'll be a sign-up sheet for that on November 28th, so just keep an eye out for that if you want some extra time before you turn your final paper in. The whole long spiel, okay? Again, if you want to reference any of this stuff, it's not quite in the exact same format as I just went in, but all the main stuff that I just went through, all the techniques are right here in this graphing tutorial. This is part 1 and part 2, so you can find those there if you need an extra reference to major graphs. All right, that's all I got for you.